and on we'll go, through the wastelands, through the highways, and on we'll go.
So this is the video that you watched. It told you about the uses of the matrices, how we use it in linear system, in statistics, in geology, and many applications in our life. Also, if you read in the internet, you will see that they use it also in computer engineering. But most of the uses of the matrices is engineering and in business. Let's start today with our chapter. We will start with the first lesson, adding and subtracting matrices. Now, matrix is a singular, matrices is a plural. Today we will learn how can we add and subtract matrices, and also how to solve the equations. Now, let's talk about the matrix. The matrix, if you represent the matrix, you will make it like this. This is the meaning of matrix. Inside this matrix, we have a numbers. This numbers is arranged in column, in row, and column. Now, this element here, let's see that each one, it has a name, A. Now, the first element, if you want now to read it or to, wait please here. So now, look at the first element here. In this element here, it is in row 1. So I will say A sub 1. This one, it's in row 1. Row 1. When go with the second row, you will say it is in row 2. Row 2, row 2. This is for the number of rows. Now, the number of columns. The first A here, it is in column 1. And this one, it is in the first column also. The second element, it is in the column 2, and this one, it is in the column 2. The third one, it's in column 3, and this one, it's in column 3. So, look at the first one here. The first one, sorry, it is A sub 1, 1. What does it mean? That this element A is in row 1 and column 1. This one here. It is A sub 1, 3. That's mean it is in it's in row 1 and column 3. Each matrix, it has a dimension also. Now, how can I represent the dimension? To represent the dimension, I have to write it down here. Like this here. You have to write down. To represent the dimension, as I told you, you have to represent the number of the rows times the number of the columns. Like here, how many rows we have? We have 2 rows. Times, how many columns we have? We have 3 columns. Is it right? So I will say now the dimension here is 2 by 3.
Teacher,
Okay? Yes?
teacher, how we have 3 columns? Like the 2 rows because we have 1 and
Okay.
2, just 2 But like how 3?
Now look here. This is the columns. This is the first column. This is the second column. And this is the third column. That's why we said we have 3 columns. Now, how many number of rows? This is the rows. This is the first row, and this is the second row. That's why we say 2 rows and 3 columns.
Okay.
Okay, so this is the matrix. I represent the matrix, or inside the matrix we have a numbers. For this matrix here, each one or each element, it has a name. I have to say that this element is in matrix in row 1, column 3 as an example. And each matrix also, it has a dimension. To represent this dimension, I have to say number of rows times columns. Be careful, rows times columns. Now, sometimes, or the matrices, it's like the numbers. It can be added, subtracted, divided, multiplied, and so on. Now, if you want to add any 2 matrices, you have to add each corresponding element. What does it mean? That means the element in the first row, in the first column, should be added with the another element in the another matrices that has the same position. A sub 1 1 with B sub 1 1. A sub 3 1 with B sub 3 1. So if you want to add or subtract any 2 matrices, you have to do to check 2 things. The first one, you have to check that both of the matrices have the same dimension. Like, I cannot add this matrix, sorry, with this one. Why? Because look at the first one. What is the dimension of the first matrices? It is 2 rows.
2
Here
by
we
2.
have 1, 2. So we have 2 rows. How many columns here?
2.
2 also. This is 1. This is the 2. So we say also 2. So its dimension here is 2 by 2. Now look at the second one. For the second one, this is the rows. We have 2 rows. And how many columns we have?
3.
3.
1, 2, and 3. Now, as you see, the first one is 2 by 2. The second one is 2 by 3. They didn't have the same dimension, so they cannot be added or subtracted.
Teacher, like only when we have the same numbers
Yeah,
we add it?
yeah. But if this matrix now comes like this, it's now 2 times 2. This one, it can be added. It must have the same dimensions. Like as an example, like let's see, like fractions. You cannot add any 2 fractions, either they have the same denominator. If they didn't have the same denominator, you cannot add them. Here you have the same. If you don't have the same dimension for the matrices, you cannot add them. They must have the same dimension. The second thing here also, that if you want now to add them, you must add this element 3 with this, let's say here like this. This is 3 with this one, each corresponding element. Both of them have the same position, 1, 1, 1, 1. And also I can add this one with this number 1 here. And this 4 with its corresponding element here, which is 4. And the last one, this 2 with this 2. So if you want to add, you have to add each corresponding element.
If they are not the same, right?
If they are the same. If they are not the same, I cannot add them. Now, do you see the slides?
Yes.
Okay. Now, let's talk about adding matrices. To add matrices A and B with the same dimension, as I told you, add corresponding element, and if you want to subtract the matrices, also they have to be the same dimension, subtract the corresponding element. Like matrix A and matrix B. If you want to add them, let's have this example here. C, matrix C is a 3, 2, 4, negative 1, 4, 0. Its dimension is 2 by 3. The second one, it's also 2 by 3. So it can be added and subtracted. Now let's adding them. We said that we have this is a matrix C, 3, 2, 4, negative 1, 4, and 0. And the second one, which is D, we have a 1, 4, 3, negative 2, 2, and 4. Adding them, it means combine them. Combine these two matrices or three matrices in one matrix. Combine them in one matrix. So C plus D, it comes now as a one matrix. How we add it? I add this is 3 with this one. I add them now. Okay, which is 3 plus 1 equal 4. Then I will go now to the second element here. Now, since I take it from the first row, the second column, when I combine them, it must have the same position. I cannot put them here. It must be at the same position. So 2 with 4. Sorry. With this 4 here. It can also be added. And if you add them, 2 plus 4 equal what? Equal 6.
6.
So it will be here now. And the last one, this 4 with this 3. Add them,
7.
you get 7. Now, negative 1 plus negative 2,
Negative 3.
which is negative 3. Now then,
Teacher, we will put it up, not down.
yes, it is here. Now, because I'm going now to the second column. So if I combine them, it have to be in the second column.
Yeah, they must have like the same shape.
Yeah. Then this 4 with 2. And the last one, 0. يلا ايش فيها لازم. With this number, as you want. Okay. And 4 plus 2 is 6, and 0 plus 4 is 4. So after you combine these matrices, you get this matrix, this new matrix, which is the numbers here are 4, 6, 7, negative 3, 6, 4. And after you adding them, you will see that also, since the first dimension here, it was 2 times 3, 2 times 3, the combination or the combined matrix, it must be also 2 times 3. This is
Teacher,
how to adding them. Yes, miss.
teacher, can we take 5 minutes from period because we have after that a quiz?
Okay,
Thank you.
you're welcome. Now, let's subtracting them now. To subtract them, you have to do the same. Here we have 3, 2, 4, negative 1, 4, 0, minus 1, 4, 3, negative 2, 2, 4. Let's now subtract them. They have the same dimension? Yes. So we can subtract them. Now, 3 minus 1 is 2. 2 minus 4 is negative 2. 4 minus 3 is 1. Which 3 and which 4? This 4 and this 3. The answer here is 1. Negative 1 minus negative 2. Be careful of the signs. Negative 1 minus negative 2. That's mean negative 1 plus 2, which is 1. And 4 minus 2, which is 2. And 0 minus 4, which is negative 4. This is now how we subtract the matrices. Is it clear?
Yes, teacher.
Okay. Let's have this one now here. Negative 12, 24, negative 3, 5, negative 1, 10, plus. Or let's solve the minus, not the plus one. I choose A minus B. Negative 3, 1, 2, negative 4, and negative 1, 5. As we did before. Negative 12 minus negative 3. It's negative 12 plus 3, which is negative 9. 24 minus 1 is 23. Negative 3 minus 2 It's negative 5. 5 minus negative 4, which is 5 plus 4, which is 9. Negative 1 minus negative 1, or negative 1 plus 1, which is 0. 10 minus 5, which is 5. Is it clear?
Yeah.
Yes. Yes. Teacher.
Okay. Now,
Teacher,
yes, Maya.
2 times it will be 2 times 3.
Yes, it will be 2 rows times 3. 2 times 3. And the combination will be 2 times 3. Is it clear? Did you take it before?
Yeah.
Yeah, we took it before.
Okay.
Yeah.
Now, is the matrix addition commutative?
It should be. Yes. The one with associative and
I mean, like, this is the first matrix, and this is with the second matrix, okay? Let's clear this one here. If you change the order, if you add this one first, plus this one the second, will we have the same answer?
Yeah. Yeah, if it's addition, yeah.
So yeah, in addition, yes, it will be commutative. But later on, in multiplication, it will be not. Later on, we will talk about it. So don't forget.
Teacher, in this case, when you have addition, we make it commutative. It will be commutative. Like just for this reason, because it is addition.
Yeah, it's commutative, and all of us know that both of the multiplication and addition are commutative. But in matrices, only the addition is commutative. The multiplication cannot be. Later on, inshallah, in the second or the third lesson, when you talk about the multiplication, you will know that why it's not commutative. So only in addition, the matrices is commutative.
Teacher, you know that we took this lesson. It was really similar to this one with teacher Hiba, teacher Nasreen.
Oh, you talked it before.
Yeah. And actually one harder than this.
Sorry?
And actually one is harder than this one that we took now.
Talk about maybe system of equations.
Yeah, maybe.
Later on, you will talk about them. Don't worry. And I see that grade 10, it's the hardest. They have the hardest subjects in math here. After that, nothing you will take. That's why I'm trying to give you everything. Because after that, you will go to calculus. If you didn't take these chapters, no one will explain it for you. Yeah. Now. Yeah. Now, the matrix equation. As the linear equation that we know it before. If you have 3 plus x equals 7. If you solve this type of equation, what did you say? You say variable x. Yes, to solve it, you will say that this is the variable x. This variable x is added to 3. So since this variable is added to 3, I subtract the 3 from both sides. After that, I will solve it and I will find that x is 4. This is how to solve linear system. Here also, we have to solve the matrix. Help me to find not only one linear equation. They can represent this 3 here and this 7 here. They help me to solve the system of linear equations. and it can be represented by a matrix. How it will be now? Like 1, 0, 12, 3, 5, 9, 7, 8, negative 2, plus A equal 8, 11, 9, negative 5, 5, 2, 10, 7, and 8. It's like this. It's like 4 plus 4 plus A equals 7. To solve 4 plus A equals 7, what did you say? You say I will subtract 4 from both sides. Here we have the same in matrices. You will know A, or you want to find now A. What did you say? You say A is, let's subtract this matrix from this one, like moving them to the second side. So A, it will be A, it will be now. بلاش. And so on. Okay, so here we will subtract the first matrix from the second one to find A, as we did in the linear equation. Now, as you need 5 minutes, I will stop here today. Inshallah, on Sunday we will continue a matrix equation. We will talk about also the some of the properties of matrices. See you on Sunday. I will stop here now.
Thank you, teacher.
Thank you, teacher.
And good luck in your. Thank you. Have a nice weekend and good luck.
Thank you.
You too, teacher. Goodbye.
Bye bye.